so end of the product. Okay, so what are the strategy we can make, and again we can manufacture the product, and we can sell once again. Okay, so what are the different types of strategies we can update in the product. Okay, whenever assume that okay the product is at the end of the cycle, or you can say at the decline stage. Okay, the product is in decline stage, so what are the strategies we can update, okay, in the existing product, and we can supply to the customers. Okay, if they're satisfied, then okay, then you can tell then you can manufacture the product and you can sell for the customers. Okay, if they're not satisfied, then okay, you should go for new product development. So I told you these things in the previous class. So I've explained about the this diagram, right? That is EOL product collecting is nothing but end of life product collecting. So that is information, so that will be collected, okay, once the decline comes into picture. So if you say in product life cycle management, so decline. So decline comes at the end of the cycle. So decline comes at the end of the cycle. Then we should do the inspection. Inspection means, okay, which part has been failed. Okay, which part has been failed in the product. Okay, then so to do the inspection, okay, we should do the means disassemble the parts. So once we disassemble the parts, then we can know which part has been broken, or whatever it may be. Okay, which part has been failed, so that we can throw, or we can dispose that part, and remaining part we can do the recycling is nothing but, okay, we can take those parts, and we can update only the part which has been failed. Okay, only we can take like cylinder. Okay, you can replace the cylinder in the engine, and we can use the same engine, okay, and we can supply the same product for the customer. Okay, this part remanufacturing is nothing but, you can say, the end. Okay, part remanufacturing is nothing but, if in the engine, if all the parts are failed, or if it is not working, then we should go for new parts to manufacture new parts, or you can go for new design, whatever it may be. Okay, the whole product you can remanufacture, or you can go for a new product development, and you can use in that car. So these things I told you in the previous class, right?
Yes, sir.
So this is the strategy. Okay, students, can you hear me? Hello, hello, students, can you hear me?
Yes, sir.
Okay, so I think I've explained you this flow chart, or this diagram in the previous class. So if I ask these strategies, okay, you can explain these 5 different types of strategy what you can make. One is repair, then is refurbishing, then remanufacturing, reuse of components, and material recycling and disposal. Okay, so after the end of the life of the product, okay, in the decline stage, so what are the different types of strategy you can use, and either, okay, you can go for a new product development, or you can go for recycling. So recycling means which are the products, okay, that has been failed, so we can replace so those products, and we can use other product, okay, which are the products which are good, we can use which are in working condition, we can use those products, those parts, and which product has been failed, okay, we can replace that product, and we can supply again to the customers. If all the parts are failed, okay, if it's not working correctly, then we should go for new parts, we should manufacture new parts, and we should replace the engine, okay, in the car example. Okay, that's an example. So if you want to develop a new product, means new design, then again you can go for new design, or new product development. So if you develop new design, then we'll go for manufacturing, right? That is called as part reuse or part remanufacturing. So if the parts of all the parts has been failed, then we will go for remanufacturing. Okay, so if a single part, or a one part has been failed, then we will dispose that part, and we will recycling is nothing but, we'll use this other parts, we'll use the same, and whichever the part is failed, okay, we should replace that part, and we will supply the same engine, okay, for the customers. So what does this indicates? Can anyone tell me? Well, what does this sketch indicates? Anyone?
Sir, it's again, I think so. The same, sir. You said once the product gets damaged or something like that, sir.
Yes.
So how can you reuse the components or like remanufacturing them to make the new product or like just repair the old product?
Okay. See, whatever the sketch I have written here. Okay, this is the same sketch. Okay, that is reuse of product. Okay, if only one part is been failed, okay, then we can replace that a single part and we can use the same product, right? Then remanufacturing of product. If all the parts has been failed, then we should go for remanufacturing of product. Okay, then recycling of product. If only one part has been failed, then all parts we can recycle the same, we can use the same product, same parts, and only which have been failed, okay, we can replace that product in the that part in the product, then we can use the same product, okay, in the engine. Okay, then recovery of components. What is this recovery? What is this recovery, students?
So like I think for this might be like assume they are like a part which has various parts, and in that like most of the parts are damaged. So other parts can be like recovered from it and can be used for some other like a new product.
Yes, good, Sachin. So recovery means whichever the parts, okay, which are working in good condition, we can use those parts in the other machine or other we can use the recovery parts, okay, in the other cars. Okay, and what is this last? What is this last? Can you tell me? See, this DIMS means dismantling. Okay, dismantling, or you can go for SHRED means shredding. Okay, or and recycling of product. So this is dismantling or shredding or recycling of products. What is the meaning of this?
So like it's either you dispose of the product or you update the product so that it again gets sold very well later.
Okay, good. So disbanding means disconnecting the pieces or the parts, okay, which has been failed. Okay, dismantling means nothing but we'll take the product, and whichever the parts has been failed. Okay, we should disassemble the parts, and whichever the part has been failed. Okay, we should replace so that part in the product. Then stretching is nothing but the product which has been weared or teared more, and means which are the failed. So so dismantling is nothing but, okay, which are the parts which have been failed. Okay, we will try to we will try to disassemble first, and we'll check which are the parts that has been failed. Then we will replace that part, okay, in the machine or in the engine or whatever it may be, okay, depending upon the application. So we will try to replace that part in that. Stretching is nothing but wherever the parts have been teared. Teared means, okay, that is worn up wherever the wear is more. Okay, so that we will replace those parts, okay, in the machine. And last is recycling. So you know what is recycling? Recycling, that means which are the part is good, which are the part is working well, so we will recycle that part in the coming machines, right? So these are the what you can say different techniques. Now different strategy what they will use. One is they will try to reuse of product, means if the parts are working well, so we'll try to reuse that product in the further machines. Remanufacturing of product, if all the parts are been damaged, then we'll go for remanufacturing. Recycling, so whichever the parts are working well, so those parts we'll use, and we will try to use those parts in the further machines. So this, see, I'm telling you this under whenever the machines means whenever the product has been come to decline stage, whenever the product has been stopped selling, so at that particular point we'll take that product and we'll analyze which are the parts, okay, that are working well, which are the products has been damaged. So which are the products has been damaged, okay, we will throw them. I mean, we will throw that. Which are the product are working, which are the parts which are working well, okay, we will take those parts and we will update in the new product. Okay, then recovery of components, and last is dismantling or shredding and recycling of products. Okay, this is an sketch. You can see in the exam you can write this diagram. Okay, so this diagram represent you can explain neatly You can also explain this sketch also. And this is the last sketch. Can anyone tell what is the meaning of this? They written level 1, level 2, level 3, level 4, level 5. In this C11, C21, C22, what is the meaning of this? Can anyone tell me? This is called as true diagram for the analysis of this disassembly depth. Can anyone tell what is this?
So I think it's like disassembling the parts again and again and checking which parts are working well and which are not working well. So just like removing the unwanted parts and just keeping the parts which can be reused later for the product, sir.
Yes. So if you go for the company, actually once the disposal comes into picture, once the product has been once they dispose these products, then while disposing we should check, right, whether which part is working, which part is not working, so which part has been damaged. Okay, for that purpose they will call this tree diagram. Okay, if they mention tree diagram, so that indicates you should disassemble the parts. If you take car, okay, this is C11 indicates a car. Okay, if you take car, so in this, so there will be three sub assembly, that is sub parts, C21, C22, C23, like your transmission system, engine, or your the third one may be the rear axle or front axle. Okay, so there will be three parts in you see in the again, if you take 3 to 1 as the engine, again you will be having the cylinder, pistons, connecting rod. Okay, like that. Okay, this is called as tree. For individual sub assembly parts, okay, how much part has been assembled. So this is called as, okay, we should check each individual, okay, with respect to an object, or you can say a product. If you take C11 as a car, so in that, so there will be a lot of sub assemblies and parts will be there. So we should check everyone, right? So every part we should check, right?
Yes, sir.
So C11 indicates for level 1. Then again the second C21, C21, C22, C23 indicates for level 2. Then again, if you go for checking the sub parts, so that will become level 3. Okay, again C31 indicates again, so there is a 3 parts. So this part is level 4. So like this, okay, you should keep on checking the parts, okay, inside the product. So this is called as tree diagram for the analysis of disassembly depth. So you should keep on disassemble the parts one by one, and you should check, okay, which part is working and which part is not working. If the part which is working, so we can reuse that part, okay, in the further machines or further products. The part which is not working, okay, so that part we can, that means we can dispose. I think everyone has understood, right? This is very important. So they will call this as tree diagram. Okay, if they tell tree diagram, then you understand. So tree diagram indicates for a product, so there will be sub assemblies will be there, sub parts will be there. So you should keep on disassemble the sub parts inside the machine or inside the car, so that you should check one by one. So which part is working and which part is not working, right? I think everyone has understood.
So one doubt, sir.
Tell me, Sachin.
Like in exam, if you ask this question, should we like mention the 3 branches, sir? Like I think even the 2 is enough, no, sir. The
No,
C21 and C23, sir.
No, you if you enough 11 and 11 to 11 3 is enough. It's enough.
Okay, sir.
So see, the main thing is you should explain this sketch. So this sketch is very important, right? So this is a strategy. Then this sketch, after this, you can write sketches, and you can explain a little bit, like 7 to 8 lines. If you explain, that's enough. Okay, the main part you explain. Anyway, I will send the notes for you. Okay, in the notes everything will be there. Okay, the theory part you can see in notes. Okay, this for sketches you see the PPT, because sketches, the notes you cannot see the sketches. Okay, this sketch is not there in the notes. Okay, the lot of sketches what I mentioned, okay, you cannot see in notes. Okay, the sketches you take from PPT and explanation you can see in the notes. Okay, students.
Okay, sir.
So anyone has any doubt in the strategy for recovery at the end of life, then we can go for modeling and simulation. This is the last topic of your second module. So this is, see, these things are not there in the notes. Okay, you should use the PPT only. Okay, to read the modeling and simulations. Okay. So anyone has any doubt in this strategy, then we can go for next topic, the last topic of second module. Okay. So modeling and simulation. Okay, according to you, what is modeling and what is simulation?
So modeling might be like assembling the parts on computer and checking out, and like simulation is like testing phases. Like you can check for either the material is strong enough to withstand a certain amount of load or not, and like again recorrecting the design before manufacturing, so you can prevent the losses. Like if you produce a product, you're simply wasting the material if it's like not going to be sold later. So those
Okay.
all phases can be done on computer like softwares, and you can correct it later again.
So good, Sachin. So modeling and simulation is nothing but first I think you have studied the process, product process, right? Product process, this one. So first is the concept based, right? Concept based. First we will see the concept, right? After the concept, this one product design process. If you see the product design process, in product design process, the first one is the concept design, right? So once you generate the concept design, okay, directly we will not go for manufacture. Directly will not go for manufacturing by parts. First, we should do modeling by the some software like CATIA or Creo or whatever it may be. Okay, we should use the software to generate that model, right? Whether to see whether that design looks good or not. So, right, students, whether the customers are satisfied or not, right? So, right, students, hello, can you see? Can you hear
Yes,
me?
sir. Yes, sir.
So that is called as modeling. So modeling is the thing what, so directly no one will go for manufacture the part. Okay, once you got the concept design according to the customer needs, then we will use the software. Okay, then we will develop a model. Okay, regarding to the concept, what you got, what you got in the brain. So whatever the according to the customer needs, we will try to draw the model. So that model initially we will try to convert that model into the 3D model by using the software. So that is called as modeling. So modeling, you can see here, modeling is the act of building a model. Example, it may be pump, it may be compressor, it may be valve, it may be turbines, blade, or it will go for anything, okay, any application. So, or you can go for engine, the connecting rod. So first we will try to imagine, okay, according to the customer needs, okay, the product design engineer, okay, we'll try to design the model with respect to concept. Then the concept design will go for real design by using the software. They will not go directly to manufacture. First they will try to analyze, okay, in software. Okay, then what is simulation? So simulation, you can see simulation is the process of using a model to study the behavior of and performance of an actual or theoretical system, right? So simulation is nothing but once you develop a 3D model, okay, whatever you have got the concept will convert into the model. Then after that we will apply the boundary conditions to the model, and we will get the solutions, right? See what you want. If you want stress, if you want strain, if you want deformation, right? All these things we can find in simulation, right? By using by using the ANSYS, or it may be Abacus, or it may be Nastran. So we'll use the different software to get the results, right?
Yes, sir.
So modeling is nothing but whatever you got the concept, you will try to model in a software like Creo, CATIA, or Pro-E. Okay, once you convert your concept into the real model by using the software, then we will take that model and we will analyze. That is called simulation. So we will try to apply the boundary conditions according to the needs, customer needs. We will apply the boundary conditions and we will find the solution. So like behavior and performance means, so what is the properties of the model. So if you apply the boundary conditions, so what may be the stress, okay, which will be produced, what may be the strain, what may be the deformation for this particular load. Okay, if you go for the thermal problems, okay, you will find the temperature. So if I apply this much temperature to the body, so what may be the flux, okay, flux it may be generated, or what may be the stresses, the thermal stresses which will be generated inside the material. So this is what is called a simulation. So modeling is nothing but model which will convert, okay, whatever the concept means will be generated, so that will be converted into the model by using the software. So similarly, okay, we will use the simulation softwares like ANSYS, Abacus, Nastran to get the results. Okay, to get the results, okay, we will use this software. Okay, in simulations, you can see in the third point, in the simulations, models can be used to study that is existing or proposed means characteristics of a system. So to find the solution, right? To find the solutions according to the customer needs, okay, we will do the simulation. See, what is the purpose of modeling and simulation? You can see there are 3 points. One is here, solve real world problems safety and efficiently, right? So see, if you go for see, once you got the concept design, okay, then you go for experimental. Experimental is nothing but, okay, you should create the prototype of the model of your concept. Then you should test, right? So once you do the test, okay, if you see if you assume that for a particular load, okay, the material is failing, so what you will do at that particular point? Your time is wasted, your invested money is wasted, right?
Yes, sir.
Right, students. So the main thing is cost. So cost of the material, okay, you should manufacture the material, the cost will be wasted, as well as your time, okay, time for manufacturing the products, likewise, okay, for testing, okay. So you should do the equipment. For so equipment cost will be wasted, so everything will be wasted. For that, what we will do first, we will try in the software, okay. Then if it then software tells for this particular load, okay, this material is safe, then only we will go for the experimental, right? So by using this software, okay, we will take the real world problem and we will try to analyze, and we will get the results. Depending upon that results, then we'll go for manufacturing the products, right?
Yes, sir.
So mainly the software will be used for complex problems. So if you go for steam turbine blades, if you go for compressors, okay, these problems are these complex problems are very difficult, okay, to solve by practical. So practical means by experimental, okay, because you should invest a lot of money. If you go for steam turbine blades, Pelton wheel, or it may be the the hydraulics, the turbines, Pelton, or it may be the Kaplan turbines. So to manufacture the turbine blade, okay, it costs around 1 crore rupees. So it's very difficult, okay, whether the design is okay or not, or safe or not, okay, we don't know. So initially we will design the model according to the conceptual design. Then we'll convert into the model by using the software, okay, 3D modeling by using CATIA Pro E. We will analyze first, okay, at what velocity the the water is hitting the blades, okay. Then we will analyze, so what is the maximum stress, okay, the material is the blade is getting. Fatigue test, whatever the test you want, okay, we can do by the simulation. Once we get, okay, the results are okay, the results are showing safe, okay, the material is safe, okay, or the structure is safe, then only we will go for the experimental, right? Then we will make a small prototype, and we will test according to the boundary conditions, okay. Then in the prototype, if it says the material is safe, then only we will go for the actual prototype, that is called as real world problem, okay. After that only we will go for actual prototype, and we will test. So anyone has any doubt in this? See, mainly the modeling and simulations will be done for complex problems. So not like, see, if example, you take your bar problems, or you can go for trusses, or you can go for beams. So if for simple like bars or trusses, okay, or beams, we can solve easily, right? How you can solve, Sachin, for those problems?
So we can either use the FEA system or we can even solve it mathematically, sir. Like we add
Yes,
in
good.
this.
Good. In the mechanics of material, right? So
Yes, sir.
if you take beam, or if you take bar, if you take trusses, if you take torsion, okay, for simple structures, we can use the theoretical method. So there is no need for software also. By your hand, you can find it. You can get this. You can get the solution, right? So
Yes, sir.
there's no required for software. So the software is used for only to see the result between your theoretical method as well as the experimental method. So whether you are getting the same or not. Sorry, theoretical method as well as the numerical method. That's FEA method. Okay, whether it is showing same or not. I think Sachin has done the rectangular plate table, right? You have done analytical method as well as numerical method, and you are seen, right?
Yes, sir.
So that is for a simple problem, okay. That is a rectangular with a hole. So it is a simple problem. But when you go for complex problems, like your turbine blades, or you may go for the compressors, pumps, okay, the designs will be complex. The shapes, the shape and size will be complex. So for those complex shape and size, we do not have the equations, right, to solve. There is no equations in that particular point, okay. We'll go for the numerical method, right?
Yes, sir.
So for complex shape, there will be no equations will be there, mathematical equations will be there. So that we'll go for FE. Okay. So for simple problems, you can use the equation. Okay, like whatever you saw, you told mom metals of metal, there will be a lot of equations will be there. So we can use that equations and we can find the solutions for simple bar, simple truss, and simple beams problems. So this is what, okay, only we will use the FEA for complex problems, complex shapes. Okay, because the software is used for modeling and simulations. I think you know, right? See, Ansys is there, Ansys, MATLAB. Then see, right now there are a lot of companies are using COMSOL multiphysics. COMSOL, okay, COMSOL multiphysics. Okay, there are a lot of companies they are using this. Okay, right now from last around 3 to 4 years they're using this multiphysics, and you can go for ChemCAD. Okay, these are the things with the chemistry. But when you come for the Abacus, Nastron, Patron, then Hypermesh, okay, MATLAB, okay, these things are with respect to the mechanical problems. Okay, if you want to find the thermal rated the problems are structural or fatigue, then vibrations. So all these problems you can solve in ANSYS, Abacus, Nastron, Patron, MATLAB. You can solve in MATLAB also. Okay, then you can use the Hypermesh. Okay, so these things are called as software, different software. Okay, we'll be using for doing modeling as well as the simulation. Then, so what is this five? One, I have written five. Right? What is the meaning of this? 1, 2, 3, 4, 5.
So those are the advantages, sir.
Okay, good. So these are called as advantages. Okay, when you use this software, so what are the advantages? One is risk-free means environment, right? Because we are not doing practically, right? We are not going to experimental. Only we will create the model in software. We'll apply the boundary conditions and we'll find the solutions. So there's no, what you can say, there is no pollution with respect to the environment, right? There's risk-free environment. Next, save time and money. So both, right? You can save the time to manufacture the product and you can save the money, right? So there's no investment in the money for materials, right?
Yes, sir.
Either investing money for purchasing materials for doing the experiment. Okay, there's no need for money. Okay, then you can save the time. So everything. Okay, these are the advantages. Okay, but if you use software, then visualization. What is this visualization?
So it's giving the conceptual designs. Like instead of starting the product and manufacturing, then giving it, you can just make a conceptual design, then ask for the customer whether they are fine with the design or not, and then you move to other steps.
Okay, good. So we can see the design part, 3D modeling. So if you're not okay with the design, then immediately you can change, right? But
Yes,
if,
sir.
but if you go for manufacturing and if you convert your 2D to 3D, so once it is converted to experimental means the model, then you cannot change. But in if you use software, you can change number of times. The design you can change number of times. Student, wait for 2 seconds. Okay, so this students. Okay, so next, so visualization is over. So insights into dynamics. What is the meaning of this?
So you get to know like how your product will work, and dynamics is like whether it can withstand that amount of load or not. So if you want to make any changes, you can make after like just going through the process simulation softwares.
Okay, so dynamics is nothing but The static is nothing but only you will apply the constant load for the material or for the body. So dynamics means okay, due to fatigue, due to creep, due to the vibrations, okay, how the material is going to get failure. So mainly the material will be failing due to the vibrations, due to the uh, uh, due to the vibrations as well as due to the fatigue. Mainly due to these reasons, the material will be okay failing. So this is fourth step, insight into dynamics. So if you want to find like fatigue or it may be creep or whatever it may be, okay, you can find easily, right? So there is no
Yes,
need
sir.
for doing experiment. Again, there is no need for experiment. You can find the results here. Okay, if you get result negative, then again you can go for to redesign the model, right? Then by doing all these things, okay, you can increase the accuracy. This is the fifth step. You can increase the accuracy of the results. So if assume, okay, if you apply the load, okay, if it is failing, then immediately we can change the design and we can increase our accuracy, right?
Yes, sir. It's
So
just like
this,
kind of reducing the errors, sir.
yes. So these are the five important what our these are called as advantages. Then we'll go for modeling and simulation. So I told you about modeling, right? The modeling is the process of representing a model which includes its construction and working, right? So, right, students.
Yes, sir.
So, what I told you now, okay, it's a form of words. This model is similar to the real system, which helps the analysis to predict the effect of changes to the system. So, see, first we will try to analyze, okay, according to the customer needs. Then we will do a concept design. Once you convert the concept design into the embodiment design, okay, we'll consider all the consideration of the design. In embodiment design, we'll consider everything. Then it will go for detailed design. Once detailed design is over, then according to the detailed design, we will take the model and we will construct that model by using the software. Okay, by CATIA, ProE or whatever it could be. So that's called as real system. So real system means nothing but once it converts from the conceptual design to the detailed design. So detailed design, we will take the original design. Okay, whatever we have done in the what you can say in the design process, the same design we will take and we will try to model, okay, in the software, okay, like ANSYS or so like in CATIA or ProE. So that helps the analysis. See, analysis is nothing but who will find the results, okay. So the job is analysis is nothing but applying the boundary conditions, like wherever it is fixed he will fix the material, wherever we should apply the forces or whatever it may be, the moments, forces, whatever it may be, okay, he will apply the forces and he will tell the effect. Okay, what effect is nothing but the results. Okay, result, what is happening in the model, so what is happening in the problem. So if you give the real model or if you give the actual model to the analyst, okay, he will do the analysis and he will tell the results. In other words, you can see modeling is creating a model which represent a system including their properties, right? So you should tell the properties, right, which material you are going to use. So only creating the model is not okay. You should tell which material you are going to use. So depending upon the material, so the like aluminum, if you said aluminum, the properties of aluminum will be different, right? If you take mild steel, if you take the polymers, so different material will be having different properties, right, students?
Yes, sir.
So according to the applications, okay, where you are solving or where you are implementing your design, and you should tell the material also which material I am going to use in this example steam turbine blade. So which material? So right now they'll be using the titanium. Okay, titanium material. So if you convert into the polymers, so then you should tell so what are the properties. Okay, and you should give the properties and you should solve. So you should tell the properties for the analyst. Then only you will apply those properties to the in the software. It will update and you will find the results. So it is an actual or act of building a model. Okay, this is about modeling. So when you come for simulation of a system is the operation of a model in terms of time or space, which helps analyze the performance of an existing or proposed system. So you will give as a design engineer, product design engine, okay, you will give the actual the real design for the simulator or the analyst. he will do the analysis and they will give the results again for the design product design engineer. So in other words, you can say simulation is the process of using a model to study the performance of a system, right?
Yes, sir.
So it is an act of using a model for simulation. So we will use this, you will use that model, real model, and you will try to get the results. Okay, and you will tell the what is happening in the model. So you will apply the boundary conditions, you will solve the problem, and you will tell so what is happening in the model, whether this model is safe or it is not safe. If it is safe, then you will tell you can go for manufacturing. If it is not safe, you will tell kindly go for means another concept. Okay, this design is not safe, go for another concept, so that once you convert that concept into the model, again give back the model for me, I'll do the analysis and I will tell you the results. So anyway, okay, so same thing, easy to understand, easy to test, easy to upgrade, right? So these are the advantages, right? So, right, students, easy to understand.
Yes, sir. Understood, sir.
Allows to understand how the system really operates without working on real time system. So real time system is nothing but okay, actually so once conceptual design is over, okay, one concept to the means embodiment design to detailed design, then it will go directly to the manufacturing department. Okay, they will try to manufacture the product, then they'll go for test. So that is called as real time system. So they will check real time. They will manufacture the product, they will apply the boundary conditions, okay, experimentally, and they will solve. Okay, so if you use this modeling and simulation, so all these things are eliminated, right? Means we should not do first. If you do here in modeling and simulation, we will get the idea whether the material is going to safe or not. Then we will go for real time system, right? See, without which here operate without working on real life system, real time system. So this indicates okay, we will not go directly to the manufacturing of the products, real time system. First we will do in modeling and simulation, then if results are okay, then we will go for real time systems, right? Then easy to test, then easy to upgrade. So in testing, assume okay, if it is not safe, then we will try to update the design, right? If you want any changes in design, we can make easily, right? There's no wastage of material. This then you can save the cost, you can save the time, everything, right? To manufacture the products, everything will be saved by using this modeling and simulation. Can anyone tell me what is the disadvantages in the modeling and simulation? Can anyone tell me?
So I think the only disadvantage might be like the software cost,
Sir,
sir.
we cannot feel the product, sir. Like, sir, it is a simulated product now, sir. So we cannot feel it, we cannot see it in person. That is a disadvantage.
Okay, Sachin, and the second thing is what you told, only the investment cost, right?
Yes, sir.
So
The initial investment cost will be little high, like based on the software used.
okay, good, Sachin. So the first disadvantage is the cost, that's investment cost. So we should invest the cost for the software, right? CATIA, it may be ANSYS, or it may be Abacus. If you go for industry, okay, they'll be giving around 40 lakh or 50 lakh rupees. Okay, if you go for the companies, okay, I think Kenyametal. In Kenyametal, they are using the ANSYS. Okay, ANSYS Workbench. For every year, okay, renewal, okay, they should give around 45 lakhs to 50 lakhs. Okay, so this is what is the initial cost is very high. So that is one thing. And second thing is see practically if you want to manufacture the products, yeah, so there will be a lot of crystal imperfections will be there, okay, in the material. But when you solve in software, okay, the software will not take the crystal imperfection, right? So there will be error in the results. Okay, if you take the practical results, and if you take the ANSYS results or the numerical results, okay, it will vary because of the crystal imperfections, okay, that will be present inside the material. What is crystal imperfection? Can anyone tell me?
So I think it's based on molecular level, sir. Like they're not tightly placed or like some problem in the structure, sir.
Okay, good. So there is a vacancy. There's a vacancy type of defect. So there's a if you open the MSM subject, okay, you can see the crystal imperfections. So crystal imperfections are nothing but okay, the atoms will not arrange. neatly. Okay, that's homogeneously. The atoms will be having some vacancy defects, or it may be or it may be line defects or edge defects. Okay, practically in practical cases, 99% all the material will be having the crystal imperfections. But when you do in ANSYS method or numerical method, the numerical method will take the atoms are arranged neatly. Okay, inside the material, it will be arranged neatly, homogeneously. So it will give the accurate results. Okay, depending upon the mesh size, how much you will get, how much you will give the mesh size. So depending upon that, and it will take directly assumption. Okay, the atoms are arranged neatly. But practical cases, if you manufacture by casting method or whatever the different methods, okay, there will be crystal imperfections will be there. So that results in the error in the results. Okay, so these are the two disadvantages. Okay, in the modeling and simulations. Then you can okay, disadvantages anyway I have written here. So whatever I told you, okay, it's similar. So designing a model is an art which requires domain knowledge, training, and experience, right? So whoever who's doing the designing, so you should know the software, right?
Yes, sir.
So that is one thing. Who has domain knowledge, so you only can make the model means correctly. Then operations are performed on the system using random numbers. Hence, difficult to predict the results. So if you take the mesh size example, if you go for mesh size, if you take 3 mm mesh size or 2 mm mesh size or 5 mm mesh size, the result varies, right? So that is called as end result to predict the results. So it is very difficult to take this is the actual results. Okay, when you do the analysis, okay, if you vary the mesh size, okay, so the element size, the results will vary. So we cannot take, okay, this is the 100% accurate results. So that is the second disadvantages. And third is simulation requires manpower, and it is a time consuming process. Manpower is nothing but to do the analysis. So you want a manpower, right? So one should be there. One should apply the boundary conditions. You should solve, right? If you go for nonlinear analysis, it will take around 2 days or 3 days time. If you go for steam turbine blades, if you want to do the fatigue or creep analysis, okay, nonlinear analysis, okay, it will take 3 days, 2 to 3 days you want, okay, for complex shapes. So it required lot of time. Okay, students, can you hear
Okay,
me?
sir.
So if you go for the nonlinear analysis, okay, see right now you can take a simple problem, and if you do the nonlinear analysis, okay, you see how much time it required to solve for nonlinear analysis. Okay, so it will take lot of time for complex shapes. Then simulation results are difficult to translate. It requires export to understand. So it's very difficult to means translate. Okay, so immediately we cannot tell, okay, this is 100% 100% okay. Okay, so next, simulation process is expensive, that is cost. So investment cost is very high, okay, for these softwares. Then can you understand this? What is the meaning of this flow chart? Anyone?
Yes, sir.
What is that
The
flow chart
first thing
indicate?
is you have a problem statement. Based on that, you give design. So you make a conceptual design and ask whether the customer is happy with the design or not. After verifying that whether he's happy with the design, if he accepts it, you go with the next phase, like converting that into like a 3D model, and then testing. Like after converting into 3D model, you again ask for the confirmation whether they are fine with the dimension of the product, and then they like choose the material, and they say like whether it'll be able to function as per the requirements. If not, they'll again like redesign it or like make some changes in the earlier phases. And
Yes.
after that, when they are like verified with all the things, like whether it will function properly, whether it's meeting all the dimensions and all the strength and the material thing, then they'll go with the implementation, which is like manufacturing a prototype of it.
Yes, good, Sachin. So what was the Sachin told? Okay, it's correct. This problem formulation according to the customer needs. Okay, we will go for problem formulation. Then setting of objectives. Okay, then we'll set the objectives. So objectives means okay, this material should sustain this much load. So there is an objectives. Okay, if the customer tells okay, this is the load which the material should withstand. So that is called objectives. And overall project plan. So how I should finish my project, within how much days we want to finish the project. So this is called project plan. Then model concepts. So that is called as once you define the problem statement, then we'll go for the idea generation. So idea generation is nothing but model concept. After that, we will take the data collection. See, data collection is nothing but the properties, the material properties, right? So we'll go for FEM. After model concept, we'll go for data collection. What are the properties we should import? So everything. Then model translation. Once you get the properties of the model, then we will try to convert 3D model. After that, we will apply the boundary conditions. Okay, we will verify and we will validate. Okay, in the validation, if it tells the model is safe or the material is safe, then it will go for experimental design. Once it is not, once the result is telling that it is not safe, then again you should go for the model concept. See here, yes, it will go for experimental design. No, again it will go for collecting the data. That means you can replace your material. So from aluminum to mild steel, from aluminum to polymer, whatever it may be. And if it is no, again you should go for model concept, right? Again you should change the design. Okay, again you try to model 3D modeling, verify your model, then validate. After getting results, again validate. Okay, then again come, if it is okay, if the design is safe, then you will come for experimental design. After experimental design, okay, then go for production runs and analysis in the sense of whether actual model, whatever you have done in 3D model, okay, it should match the experimental design. Then after go for analysis, whether do the test. Okay, actual test. Once you do the test, okay, if the material is safe, then go for documentation and reporting. That is, the material is safe for this particular load. Okay, the material is safe. Then go for implementation. Implementation is nothing but go for manufacturing of the products. I think everyone has understood, right?
Yes, sir.
So this is very important in the industry. Okay, if you know this flow chart, then it will be easy to work in the industry. Okay, you should know this flow chart. Everything whatever I told you, okay, I have written the 11 steps, right? 12 steps, right? Problem formulation, setting objectives and overall project plan, model concept, then data collection, then model translation, verified, validation. Once validation is finished, that is, if the material is safe, then I will go for experimental design. After that, production runs and analysis. Okay, after testing, okay, if it is okay, then we'll go for documentation and reporting. Then we'll go for implementation, means nothing but okay, that is a production of more products. Then modeling process. Look, what is this? Whatever I told you, okay, it's in the form of figure. Can you see and can you analyze, students? Can you see this? What is the meaning of this flowchart indicates? See,
So is it like how modeling is done, sir? Like you see the real life problem, then based on that you design it.
Yes.
Then you verify whether they like the 2D drawing or not. Then after that you convert it into a 3D drawing.
Yes.
Then you give the results of like what the materials it will take, like how it will appear and all this thing. And then you go for the simulation software after it, sir.
Okay. After that results, so once you do the analysis, you'll get the results. Then we'll go for experimental data. See whatever we explained here. So after implementation, we'll go for that is called recommendation. See, recommendation in the sense of we can go for manufacturing the products, right? That's called recommendation. Once if you see the in model frame is nothing but the answers by using the software. Okay, if it's still okay, then we'll go for experimental. So in experimental, if it is okay, then we'll recommend. So that design, then it will go for a real life product, right? Like your car, or it may be anything, phone. So while doing a phone, always you should remember, okay, they will do this, all the 12 steps they will follow. Okay, if in 12 step, okay, if it tells okay, then only they will go for actual manufacturing of the products. Okay, so this is also okay. This is also a simple sketch. Okay, you can write and you can explain. Then what is verification and validation? So what is validation, students? So it is the process of comparing two results, right? See, two results is nothing but one is experimental and one is FEM. That is your numerical method. So after doing numerical method, what you got? So after experimental method, what you got? So if you compare those two results, so that's called validation. So right. So validation. So we are trying to validate the two results. One is experimental result and one is numerical result, right?
Yes, sir.
So this is called as validation. So this indicates, see, as an example, if you do the mathematical model, sorry, if you do the numerical method first, okay, in that it is showing safe. But when you do the experimental, okay, it means it is telling it means it is going to fail within this much load. So how you can validate this?
So you can validate it by actually producing the product and testing it whether it will be working for the same duration or not.
Yes, so that's what I'm telling you. So in FEM, we got the material is safe for this particular load, but once you do the experiment, okay, it's showing that for this particular load, okay, it is not work. It means it is going to fail. So what we will do next? So what is the next process? What we can
So
update?
you need to make certain changes in the design again, sir, because like what it is saying in the theory part, you're not getting the same actual results in the practical part.
Yes. So what we should do now? Again, we should change the design.
Kind of, so, or like if you can like just improve the material or like just add certain thing in the design which can make it like get the like the actual results you want in the real life.
Okay. So we should check two ways. One is the material, the manufacturing process. So if you are using the casting method, okay, whether you use whether while manufacturing the product, whether so there are a lot of defects are there inside the material. So you should check, that is one. And second is whether whatever we have designed according to the numerical, okay, the same design we have manufactured practically or not. Okay. So example, if there is a curve, if there is a curve, so if in a design, if there is a curve, okay, somewhere, okay, the same curve it should come in practical manufacturing. Okay, if you get like edges, then so there will be a lot of stress concentration will be high, so that it may fail. So we should check the design as well as we should check the how it has been manufactured. Okay, while manufacturing, some defects will be there. So if defects are more, so the automatically we can say the material will be going to fail. So we should check, and we should check the results between these two, whether your numerical method as well as the experimental is giving the same results or not, or it may be similar. Okay, if it is not similar, then we should go for the design. We should check the design, that is first process, whether the design of mathematical model, that is design of ANSYS as well as design of practical is same or not. So then we should go for the properties. So what are the properties we gave in the ANSYS, and what is the property we are getting in the experimental? After this, we should go for the how we manufacture the product. So all these things are okay. You should do when you go for the industry. Then verification. What is verification?
So like this thing after validation you make the changes. So in verification you just compare whether if
Yes.
you're getting the same results as what you wanted in theoretical and the actual value, you go with the design.
Yes, so that is called as process of comparing two or more results for ensure its accuracy. So this is basically for accuracy, how much accuracy it has been coming. So example, in your ANSYS you're getting 12 megapascal results, but in experimental, okay, if you get 13 to 13.5 or 14 megapascal, so that is called as accuracy. How much accuracy has been exist between experimental and numerical method. Okay. So this is a simple what you can say sketch, right? Real world system. So this is the customer needs. So real world system is nothing but customer needs. The customer asking the product. Then conceptual model. So you will try to design with respect to concept. Then it will go for simulation. So that concept detailed design will go for the simulation. Okay, in simulation, if it is safe, then we'll go for the experimental. Okay, if experimental also it is safe, then that product will go for real world system, right? That is according to customer need, we will manufacture the product and we will sell for the customers, right?
Yes, sir.
Okay. So this is regarding to FEA, or you can tell. So when we will do the FEA analysis, students. So before product is created, after product is created, or sorry, after product is
Sir,
designed.
after modeling, sir.
Okay, before product is created. See,
before product is created, sir. It's just after modeling, like after you make 2D, 3D model, and
Yes.
it's verified that the customer is happy with the design, then you select the material and test it out, like the FEA analysis thing in it.
Okay, in this, which one to means you'll go either in first sketch, second sketch, and or third sketch?
Sir, we'll do before the product is created, sir.
Yes, good. Okay, that is first sketch. So be careful. Always you should remember before the product created. Okay, before that only we will try to design the model and we should analyze. So So after product is designed, so after product is designed, we cannot again we cannot go for to redesign, right? So that is once it designed, once you manufacture the product, then we cannot do anything. So after product is released, so at that particular point we cannot do anything, right? So we should remember, before product is created only we should do the modeling and analysis, FEA. Okay. So you can see here as a tool. Okay, you have class, right? Anyway, from this I will around 4 to 5 slides are there. 1, 2, 3, 4, 5. Okay, 5 slides I will do tomorrow or next week. So if I do this 5 slide, so this second module will be over. Okay. So wait for 2 minutes. Okay, I'll take the attendance. So anyone has any doubt in today's class, you can ask me.
No doubt, sir.
So within today evening, okay, I will post the PPTs as well as the assignment. Okay, assignment of your second module. So if you complete the second module assignments are around I will give 5 questions. Okay, it's enough. So first module 5 to 6 questions. Second module 5 to 6 questions. If you read, that's enough for your test. Okay. Okay, students. Hello.
Yes, sir.
Okay. See, I'll post the assignments today for second module. Okay. I'll post the
Okay, sir.
assignments, so you can read by that. Okay. You can write only 4 to 5 questions.